So today we're going to see how we can use Linkurious for cybersecurity threat analysis. So just a quick word about us. We are a Paris-based company. We exist since 3.5 years, and we help companies understand their graph data. Our main product is called Linkurious Enterprise, and it's an enterprise-ready graph visualization web app that comes with an API. We already have 200 customers worldwide, including NASA and the French Ministry of Finance. Our use cases range from fraud detection, intelligence analysis, healthcare, cybersecurity, and beyond. We are official partners with Neo4j and DataStax. So first, before going into the subject, what is a graph? A graph is a set of nodes and relationships. This is a node, and this is a relationship. Both can have properties. So here, for example, we see that Jean has a relationship with Sen, and both share the same location, Paris. So what we need to understand is that for ICM, basically security solution data are very log-centric, and the quantity of data has increased a lot in the last 15 years. This results in a very complex and in very complex sorry, I'm using my words here. Basically, we have an overflow of data that causes a growing complexity. This results for analysts that it is difficult to extract information and understand what is going on the network. Today, no SIEM solution offers graph data visualization to explore and investigate their logs, which means that basically analysts have to interpret terabytes of data without any visualization solution. This results in complex investigation and, of course, time-consuming. Cybercrime costs around 450 billion euros annually and can result in data losses, reputation damage for companies that are victims, and big legal costs if consumers take this to court. What Linkurious enables is it enables analysts to explore and investigate the log data intuitively. Linkurious can be used for real-time analysis or post-attack forensics. The idea is to detect threats, accelerate the investigation process, and make smarter, data-driven decisions. This results in saving money for the company, better reactivity of all the security team, and compliance with all the security standards. So now we're going to see Linkurious in action. For that, I used a real-life company dataset that was made public by the University of Victoria. So it came in PCAP files, and what I did was simply convert it into CSV files, modelize it, and put it into Neo4j. So you can see the model here on the right. It's very simple. You have an IP that has a port. Port is basically the service that the server is talking to, and this port has a connection to the other IP. What we get is a 200,000 nodes and 1 million edges in the graph. So for this use case, we modelized a simple DDoS attack on the network. What is a DDoS attack? A DDoS attack is a denial of service attempt it's an attempt to make a machine or a resource on the network unavailable to the users. DDoS attack often use botnets, which are basically networks of zombie computers that were either infected by malware or taken control in a certain way. So now I'll go on Linkurious and show you what a normal behavior on the network looks like, so you can understand why it's interesting to visualize. So I'm going to look for, here we are on the interface of Linkurious, and on the left I can look for a particular node that I'm interested in. So here I'm looking for just a basic node that has this address. As you can see, the search engine gives me several results, and what I want is this IP here. Here we are. So I can just centralize it. What I'm going to do is right-click on it, expand it, and ask for the least connected nodes. Here I'm just going to show 30 of them to show how to have a simple visualization. So here what we get is the IP here in pink and all the ports it's connected to. As you can see, most ports are only connected to one other entity, an IP address. So what I'm going to do is select all these ports and expand them as well to see what it looks like. And as you can see, we have, I'm going to zoom in. We have an IP address here that has connections to 5 ports and talks with this IP address here. This is relatively normal because generally an IP address talks with several services and doesn't only direct its communication to one service. Okay, so now that we've done this, let's look what an attack looks like. I'm going to hide everything, go back. So now let's suppose a particular IP came on my radar as suspicious. Do the same thing as before. There we go. So now we have this IP that has 229 edges, connections. I'm going to do the same, and this time I'm going to expand to see all the connections at once. There we are. So it's much more than the one before because it has a lot of services. And I'm going to expand again to see the IP addresses that connect to it. Here we are. All right. So here from afar, difficult to say, but if we zoom in, we realize that all the IPs have the same pattern of connection. Basically, they connect to port 25, as you can see here, and another service, which seems odd when you know that the norm is to generally talk to a lot of different services at once. If I zoom in, I can have a look at everything. But this is starting to smell bad. Oh, I have a problem with my display driver. Sorry for that small glitch. All right, sorry, I'm going to start again. I don't know what happened here. Oh, there we are. Seems my graphic card is getting a bit old. Expanded, so we get back to the previous visualization. There we are. So what I'm going to do now is basically, if my IPs have latitudes and longitudes in its properties, I'm able to basically put them on a map. This is called the geomap function. I'm going to click here, and in one click, I can visualize where all the connections come from. So if you look, it's from Europe particularly, And it seems there is a lot coming from Ukraine. Zoom in, and we can see that around 60% of all the connections come from this region over here. So we can see that it's in all the urban centers. And for example, here, I realized that an IP address has had another activity on my network that I didn't see because everything was expanded, but here it indicates that 2 more connections were not shown. So I'm going to come back here, zoom out. So this is the suspicious IP I detected earlier. And what I'm going to do is investigate it as well, because, oops. To do that, I'm just going to hide what I just saw and expand this. Now, same procedure, expanding everything. And here what I have is the activity of this IP on my network. So we see the connection with the previous IP we just saw that presumably was victim of an attack. But we see another IP on my network, and it's pretty much the same. So what I'm going to do is see if the botnet was active on this IP as well. So same goes, expand. Oops. I'm just going to deselect this one not to expand as well. And what we see is that basically the IP address was a hint that showed us that we were also a victim of an attack on this other IP on my network. So yeah, just to sum up, basically what I did was find out about an attack, realize there was something odd about this IP address right here, because it had other connections that I hadn't seen before. And it uncovered that actually the attack was much more important than what I thought before. And I have this glitch again. But yeah, so basically, that's it. If I go back to the presentation. All right. So to sum up, what we did with Linkurious here is that we investigated the potential threats, and Linkurious enabled that to do this in a very fast fashion. And now we have all the information to take the appropriate decisions concerning these attacks. With Linkurious, analysts are able to overcome the overflow of SIEM data and extract the information they need in a timely fashion. Also, Linkurious has collaboration features that enables entire teams to work together, sharing those visualization and working together. One thing we should add also, graph technology enables pattern recognition to automate the detection process. So analysts can really focus on the investigation with Linkurious. We are an enterprise-ready platform, and we come up with all the usual standards. So we are on-premise web application. We support all modern OSs and browsers. We can manage access right management, which is particularly useful when it comes to security. We support HTTPS encryption, and we have a documented API. Also, we are compatible with all major graph databases like Neo4j, DataStax, and Titan. There you go. If you have any questions, we'll be answering them after looking at the Twitter feed. I'll give it back to John.
Thank you very much, Maxime. So if you have any questions, you can write on Twitter, or you can also use the Q&A functionality of Google Hangout to ask questions. We would be happy to answer them. Once again, you can write on Twitter at Linkurious, or you can use the Hangout functionality to ask questions. So we do have a first question from Gabe. I'm going to read it out loud. How would the visualization scale as the graph becomes too large to see the individual nodes and edges? So that's a great question. In Linkurious, at a given time, you can display a few thousands of nodes and edges. It is a big restriction, and sometimes the nodes that you will be looking at will have more than this number of connections. In that case, you have a number of options to narrow down your search, basically, and to try to keep the information which is displayed on screen at a level low enough for you to understand, because your brain is also restricted. Specifically, here I'm talking about the ability to filter data. You can filter data based on any property which is in your data set. So it could be, the type of nodes, the type of relationships, or, for example, the certain property which is of interest for you, like a timestamp, for example. So these are some of the options that you have to narrow down what you display at a given time on the screen. Hopefully that answers your question, Gabe. So we have another question, once again from Gabe. So what would it look like to time phase the graph so that the changes in the graph over time could be seen?
I can actually answer this question. That's an excellent question, because basically, for the moment being, we do not support time management in Linkurious. But what I did here was aggregate all the frames to go around this problem. But time management will be one of the features that will come in the future, basically.
Okay, perhaps we have more questions. Okay, it doesn't seem like it's the case. You can write to contact at linkurious.us if you want to ask more questions to our team, and we will be happy to answer them. Thanks again for tuning in today for this webinar regarding cybersecurity and cyber threat analysis using Linkurious. Goodbye, everyone.
Bye.
Bye-bye.